So part A, determine an equation of the inverse of y equals negative x squared plus 4. Sketch the graphs and its inverse, and is the inverse a function? Again, the big idea for finding an equation of an inverse is we start by switching x and y. And then we do our math to see if we can get the y by itself. Personally, in this situation, I might bring my y squared and move my x over. You could have moved the 4 over and multiplied by -1. There's a bunch of different ways you could officially get that y squared by itself. And then the opposite of squaring is the square root, and we have to remember plus or minus. So there's the equation of the inverse. Sketch graphs of both of them. So for part B, I'm going to graph this one in blue. X squared is a parabola. Let's graph this using grade 12 stuff. X squared is a parabola. Does this negative outside make you think of vertical reflection? So I think of my parabola, flip down, and then move up forward. That'll get a vertex right there. Over 1, down 1 there, over 1, down 3. Practice thinking about these functions lots, because the quicker you can get the picture and an accurate graph of something, it's going to help you a lot, not only in this course, but next year in AP Calculus as well. So, we flipped it over. We've got our graph. Now, over here in green, I'm going to graph and if you're graphing an inverse, it's always going to be, if you have the original graph, it's going to be the easiest just to switch x and y. So for example, on my original graph, I have 0, 4, I have 1, 3, I have 2, 0, I have -2, 0, and -1, 3. It is not hard to switch the x and the y. So on my green graph, I'm going to have 4, 0. I'm going to have 3, 1 and 3, -1, 0, 2, and 0, -2. And if you imagine a diagonal line here, does your brain let you flip that? Does your brain let you flip that over top? Does it match up with a sideways parabola? Again, sometimes flipping over a diagonal line is a little bit of a challenge. Okay, couple of things to note. One, was it hard to switch x and y? No. Could you have graphed it from the equation? Yes, but I think it would have been a little bit more challenging. First of all, with the plus or minus, the plus or minus technically means you have two different equations, one with the plus sign and one with the negative sign. And if you went from left to right, on the first one, first of all, can you see that it should be a square root graph? Okay, I want to just point out that my sideways parabola here is really two square root graphs put together. Okay, that's first notice. So one of the square root graphs, well, when I look at it, what kind of reflection is that? horizontal. Does it make sense if you had started with a square root graph and then did a reflection over here? It would be in that shape. That seems to match up, right?
Mm-hmm.
And then, according to the graph I drew, it's 4 to the right. What's wrong with the equation? Did I do something wrong?
You got it.
It should be a negative to go 4 to the right, right? Because x's are liars. So either I lied to you or the equation, like something's gone wrong.
Well, the negative in front of the, oh wait, no, the negative in the x has done something.
Oh, that's a bigger reason.
Yeah,
That's not, I was going for something a little bit, wow. Oh yeah, this is wonderful. I just found out Smartboard updated. And you no longer, with the new update, you can no longer undo erasing.
Why?
That's a good idea. I love updates that go back in time. Okay. All right, let's just rewrite this. There was a negative x plus 4. And there was a dot there. Let's reenact this, and I didn't like that dot. So I went to erase it, but I wanted to. That would have been so much nicer. Yes?
Is it because negative x plus 4 is equal to x minus 4?
Close, it would be equal to 4 minus x. So this is a classic case of the special note we wrote down yesterday that I told you you could put in a review in your phone at 10 o'clock. We have a horizontal reflection and a horizontal translation. It is not in factored form. So you would first have to change this to be factor out the negative, leaving you with x minus 4, and then you feel like,
negative, so it's a liar.
and then it's a liar, and then it's going to the right as we expected. Same thing with this one. Factor out that negative. So for sure, coming from the graph, you see, going from the equation and graphing it, you have great potential for making a mistake. Which we don't want to go into that. All right, my teacher says I have great potential, but you don't want to have great potential for making a mistake. It's so much easier from the graph. But when we do it in one way, we want to check: does it make sense? Can we see the results also from the equation? Yes. Okay. Then, does it ask if it's a function? Is that a function?
Nope.
No. Not a function. Doesn't pass the vertical line test. Is there a way I could have already known from the original graph, before I drew the final graph, that the inverse wouldn't be a function?
Because if your original graph isn't just a straight line, your inverse will. If your original graph is both a function and not a straight line, it will always not be a function if you invert it.
Close. I can make something not a straight line and still have the inverse be a function. You're right that lines, their inverses are functions.
If there's 2 points with the same y value, its inverse won't be a function.
Okay, so if, for example, he's saying if there's 2 points with the same y value, I'm going to circle. Would you agree those 2 points have the same y value?
Mm-hmm.
They have a y value of 3. And then when we do the inverse and we switch things, then it doesn't pass the vertical line test. A way that we can summarize that in a very easy way to remember, and in fact they have it at the bottom of the next page at 239, so I'm going to just see if I can get there. Oh, I've got, oh, check it out. Is this what you have at the bottom? When is the inverse of a function also a function?
Yeah.
Is the way exponents odd?
Exponent will be odd, but then sometimes some exponent ones don't work necessarily either. Okay, but an x cubed graph is going to work. And what Roman said there about having the same y value, we can summarize that by saying the inverse will be a function if the original function passes the horizontal line test. So what Rowan said there, the horizontal line hit 2 points, right? He had a y value happen at 2 different x values. Then splitting those will mean that you won't pass the vertical line test. So an inverse will be a function if the original function passes the horizontal line test. Mathematically, these are sometimes called one-to-one functions, because every x has one y value and every y has one x value. And these become very important functions because then inverse exists. When this doesn't happen, we have problems like square roots and squaring. We have problems sometimes. We have the problem of sometimes you have to add a plus or minus. That felt weird. And square roots are always positive. Why can't they sometimes be negative? It feels weird. It's all this idea of what makes a function a function. Your calculator wants to tell you one thing, but we know in certain situations there are more than one right answer. For example, trigonometry. Sometimes you'd find an answer and it would be in quadrant 1, but then you'd say, but there's also an answer in quadrant 2. But your calculator only tells you one answer, because your calculator is based on the idea of a function, and a function should only give one answer. So we're going to see that a little bit when we go into our next example here. Did I give you questions for that last one?
No.
Questions for example 2 are 5 and 6.